need to go and watch the videos. And tonight's homework is going to be the rest of the back page. There's fill in the blank with a word bank, and then there's like 6 problems. And I think the answers to those problems are at the bottom. You just have to show your work. All right. Calcium hydroxide. I want to know what is the pH of it. So if I take calcium hydroxide and I break it up, it's going to break up into 2 ions. And those ions are calcium and hydroxide. To balance this out, we need a 2 there. Now the question says that it has a pH of 8.4. So I want to know what is the concentration of this. That's the molar concentration. I want to know the concentration of this, and I want to know the concentration of this. We need to find all those concentrations. So first of all, if I'm dealing with a base, but I have a pH, what do I need to do first? Find pOH, and pOH is going to be equal to 14 minus my pH, which is 8.4. So when we do that, we get 5.6. So we know the pOH is 5.6. So now I can use my pOH to find my concentration of OH. So we do 10 to the negative 5.6. So hydroxide concentration is going to be 10 to the negative 5.6. So put that in the calculator. Tell me what you get. 2.5 times 10 to the negative 6. That's the concentration of my hydroxide. What's the ratio of hydroxide to calcium? 2 to 1. What's the ratio of hydroxide to calcium hydroxide, the base? 2 to 1. I'm just looking at coefficients here, guys. Just looking here. Right? So my hydroxide concentration is 2.5 times 10 to the minus 6. That's for 2 of them. So what would it be for 1 of them? You divide it by 2. So 1.25 times 10 to the minus 6. So that means that this concentration here has to be 1.25 times 10 to the minus 6. So, yeah. That means what's the concentration of my base? 1.25 times 10 to the minus 6. Okay? So you have to look and see what are those ratios. If it's a 1-to-1 ratio, if this would have been something else, it's like sodium hydroxide, where it was all a 1-to-1 ratio, they would all be the same number. But since they're not 1-to-1 ratio, we have to divide it to find those other 2. Okay? Yes?
One more time, why is the CaOH2 1.25?
Okay, so remember, if we have whatever this concentration is, and when it breaks up, this has the same concentration, and this would have the same concentration, except for we have 2 of those. Oh. So since that one's 2, it's going to be twice that. Oh, okay? Okay, any questions on that?
So they should all have the same concentration?
If it's a 1-to-1 ratio. All right? All right, next. What we're going to talk about today is salts. Neutralization reactions. A neutralization, if I were to neutralize something, what happens? No positive, no negative. If I have an acid and a base, when I put them together, what happens is we get a neutralization. They cancel each other out, okay? So what happens here is this H ion hooks up with the OH. And we end up getting water. Sodium hooks up with chlorine, and we get NaCl. So in a neutralization reaction, we always have an acid plus a base, and it gives us water and a salt. I say and a salt. When I say a salt, I don't mean the stuff that you put on your French fries or your popcorn or whatever. A salt is a generic word for ionic compound. So anything that's an ionic compound. So if I were to have, say, HCl and KOH, my two products are going to be one, always water, and the other one is going to be KCl. All right. If we had HI and we had NaOH, our two products are going to be water and NaI. So these are, we have the water, and these are all salts. Okay? All right. Any questions on that? We're going to do a couple of these. All right. Here we go. This says that it wants us to balance it. I'm not going to balance them unless you're having problems seeing what's going on. So what's one of my products? Water. And what's the other product? Potassium sulfate, so K2SO4. So I have to go back and look at those charges. K's a +1 and sulfate's a -2. What about the next one? What's water and BaClO3 with a 2. Barium's a +2, chlorate's a -1. This one's kind of weird. This, I don't know why they do this, but acetic acid, they put the H at the back. So, again, what's our two products going to be? Water. And so lithium goes first. And then we have C. Lithium chaku. Lithium chaku. Okay? Questions? Do I need to go balance any of those? Everybody's good with? Okay. It's a metal. It's a positive. It's an anion, or cation, anion. Cation's always first. All right. You guys want to do one more? Yes? These are fun. HBr and calcium hydroxide. Oops. H2O and Ca. Ca is a +2, Br is a -1, so Ca, Br2. Next. What's the product? Water. And Rb is a +1, NO3 is a -1. Rb and O3. And final one. One of the products. Water. That's the easy one. Sr is a +2, ClO4 is a -1. That's it. So we have water, and then all those are salts. Okay? It's all multiple choice. All right, so the next one, I am not asking you to do calculations on this one here. What I want you to do is I need you to be able to set the equation up. So what we do is these reactions are called equilibrium. What means is for every reactant, so they go back and forth. That's what that arrow means. It's going back and forth. So I'm making reactant or a product, but I'm also going back and making reactant. And it's an equilibrium for every one reactant that's being made, one product being made. So, so what we need to do, and these things have values. Equilibrium expression is called K. And what we do is we take our equation. All right, I have reactants A, B, it makes products C and D. Once I take that, I always put products over reactants. Okay? And then what happens is we take our coefficients and we raise those to the power of whatever that coefficient is. So if I put a 2 there. Okay, so here's my equation. So products. So this is going to be concentration of one of my products, which is H2O. What's the coefficient in front of H2O? 2, so it's squared. Then I take my other product, which is SrCl2, and it does not have a coefficient, so it's not raised to the power, or to the power of 1. And then we put our reactants on bottom. Oh, 2, thank you. 2, right there. And so if we were to do this, I was going to give you some numbers. We just plug those numbers in and we would find a value for K. But I don't need you to solve that. I just need you to know products over reactants. So products over reactants. Okay? So we're going to do a couple of these. SrO2. First of all, it breaks up into 2 things. SR, 2 plus, and hydroxide. Okay? And we need to balance this. So I put a 2 there. Now I need to write this expression. So first of all, is this an acid or a base? OH is a base. So we're going to call this KB for base. What goes on top? All right. So if all the concentrations were 1, so this would be 1 times 1 squared, which is 1, divided by 1. So the value of K would be 1. Okay? So let's do another one. HNO3 breaks into H and NO3. Is this an acid or a base? Acid. What goes on top? H plus. NO3 minus. Over HNO3. Everybody good? We can do one more. So we're going to do Chaku here. Chaku breaks up into CH3COO minus plus H plus. So this is an acid or a base. Acid. Products. H plus to the first power. CH3COO to the first power. All over CH3COOH. That's it. Questions? All right, so very last topic we're going to talk about is called titrations. So what a titration is the following. We have this setup here. I have a burette. It's kind of like a big, huge pipette, and it holds either an acid or a base, one of those. And I know the concentration of that acid or that base. So in this burette is my known. Down here in my flask, I have my unknown concentration of, if this is an acid, then this is the base. Okay? If this is a base, then this is an acid. And in here would be an indicator. So what happens is this setup here, this is a pink indicator. It's pink when it's a basic solution. And what happens is we start dropping the acid in there, and we drop, 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 it turns clear. And it goes back to pink. Drop, 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 turns clear, goes back to pink. And we keep doing that until at one point, the very last drop drops in here, and boom, it goes clear and it stays clear. So at that point, we have shifted from having base in here to having all acid now. It's now an acidic solution. If I know the volume of this, the amount I put in, and the volume here that I started with, I can determine what my unknown concentration is. Okay? So we do that by using an equation called molarity of my acid times the volume of my acid is equal to the molarity of my base times the volume of my base. We've seen this before, right? Okay, so we use this in dilutions, except for now we're talking about acids and bases. When I take molarity times volume in liters, what do I get? Moles. So in a titration, the moles of my acid is equal to my moles of the base. We do these curves. So what happens is we put a pH probe in here. Probe, it's sitting there, say it's got a pH of 13 right now. And as I put my acid in there, it's going to start to go up, okay? So as this probe, it sits in 14, as I add acid, we see that we get this nice curve. We're going down, our pH gets lower, and then at some certain point, it stays down at 1. This middle point right there is called our equivalence point. And so your equivalence point is when the moles of your acid is equal to your moles of your base. In a strong acid, strong base situation, equivalence point is always at 7. So I know that we started with a base because my pH is greater than 7. And then it ends down here, so I know that now this is an acid. If we were to look at something else, if we were to have in my beaker an acid, then we would look something like that. We would be reversed, okay? With the equivalence point being right there in the middle. So these are really fun to do. So let's do a problem. 54 mils of 0.1 molar sodium hydroxide, acid or base? Base. So we have 54 times 0.1. To neutralize 125 mils of my acid. What is the molarity of the acid? So put that in the calculator, solve it. To 0.23. Big M. Everybody get that? Okay. If it takes 25 milliliters of a 0.05 molar HCl solution, so 25 times 0.05, and we're going to set that equal to the 345 milliliters of my base. So what is the molarity of my base? Anybody got an answer? It's probably really weak. Really low pH. Yeah, so if we put it in flow, and now hit enter. Now. So if you got 3.0, some of your calculators might pop this up. Oh, yeah, that's what it popped up. Okay. Make sure you're reading over to see if there's that over here. It's the same answer. It's just one's in scientific notation, the other's not.
Does it matter if we give it to you in sig?
No, in scientific notation? Mm-mm.
I didn't get the same thing that you did for the molar. I got 0.04.
I think that's what I was getting yesterday or this earlier. .00432. That's what I got here.
It's just
1 0. Okay. Questions? All right, we're going to do one more. And somebody asked me, is this really how easy this is? Yes. It's not going to get harder than that. 50 milliliters of a 0.5. So 50 of a 0.5. And we add it to 125 mils of my acid. And I want to know what is the concentration of my acid. 0.2? 0.2 molarity. Now my final question is this. If I know can I take an unknown concentration of one solution and titrate it with the unknown concentration of another solution? No, why not? Yes, we have to have, our equation, we have 4 variables, and we have to know at least 3 of the variables. And so if we don't have those 3 variables, then we can't do it. All right, any questions? So that's it. Your homework is the rest of that back page.